All right, class, I'm going to do this. I'm going to catch up first from last time, then show a little quick app, and then we'll jump to Lily 4.1. All good? Whenever someone is absent, I do record it. If no one's absent, I don't record them. So it's kind of just off. So real quick here, catch up to last time here first. Catch up to last time is, and again, if you don't need to write this down if you don't want to, but this is just last time here. So first things first, we start off with unit circle. Right here. And I'm going to just do some quick ones. We good? And so from the unit circle, we can always make a table. So I'm going to make a table, and I'm going to just change up the table in just a second here. So, and watch for the sleight of hand on the variables. We good? So I'm going to go 0 degrees, 30 degrees, 45 degrees, and we'll hit 90 degrees. We'll skip the 60 for now. So if this is the case, isn't this theta? And then what we do is we figure out the x and y coordinates of theta, but technically it's just sine theta. That's what we're going to get to. Okay, cool. So if theta is 0, it's right here. I got 1, 0. Sine value is 0.
Did you call it t though? Last time you had
T, yeah, that's right. So let's do this now here. So instead of dealing with an angle, because angle deals with 30 degrees, 60 degrees, 80 degrees, right? Okay, I'm going to switch now. Thanks to Abe. I'm switching this. I'm going to switch it a lot. We're good. I'm going to switch this to t and sine of t. So now I'm thinking only radian measurements. And I'm thinking about real numbers and the length around the arc. We're good. Now this is real numbers to real numbers. So t value of 0 gives me a sine of t value of 0. Agreed? Agreed.
Not just the sine is y.
Yeah, it's the y value. Dylan, you talk to me if you need to, okay? You please ask the questions as we go. Because in mathematics, there's kind of two different things we do, real quick here. Is like, one is skill-based, like 2 + 2 is 4, 3 + 3 is 6, right? That's a skill-based kind of thing, right? Then in mathematics, there's something called concept. Concept-based was like, it's going to be a light that turns on or does not turn on, right? We want the light on. And so that was like, oh, got it, you know? And sometimes it's actually a linear progression of thought, right? It goes this to this to this, oh, I get it, right? And so it's a linear progression of a conceptual thought.
So exactly for this, how do you suggest we put it down in the notes if you're going to be constantly switching between theta and t? Should we maintain two different sets of graphs? Should we maintain two different
Interchangeable, I think. You just interchangeable.
You could just write, so let me do this here. I'll keep it as, let's start off with t.
Wait, but t is supposed to be the radian equivalence of theta, right?
Correct.
Right,
But
so-
it's measuring the outside of a circle instead of the inside.
Right, so should we be maintaining a different?
Yeah, sure.
set
Yeah.
of-
I know what you're asking, yeah. Let's start off with t. T would be the easiest to start off with, and then we'll switch it. But as we switch it, I will make another table real quick here, okay? Thank you for asking. That's a good note sort of thing, because notes have to be clear. So we're not going to deal with theta, because theta deals with angles. So no, I want real numbers on one side, and I want real numbers on the other. So t value of 0 is 0. T value of 0 gives you a sine t value of 0. We're good? Boom. T value of pi over 6. You guys talk to me. It gives me a sine t value of, I don't know. It's a Monday after Thanksgiving break. 1/2.
Not just 1/2 because it's the y value.
It's the y value, because this
so-
guy becomes 1/2 here.
So I did that part, but I also have numbers written on the sides. Like I have 0.5. Yeah, like I have the 0.5, but then that's one which is pi over 4, which is 0.71. I also have 0.8. Why would it be 0.8?
Sure, we'll get there.
And
All right, let's include the 60 degrees here.
Should we sine of t or sine of 1 of t because we're trying to find the y?
No, so Dylan, you are confusing between the angle measurement and the y value itself. So if you want to find the t value, so real quick here. Sine inverse of t would actually give you this number here. We already know that number. So we're going this direction. And so we're not trying to figure out the angle measurement that makes it. We're just trying to figure what is the sine value of that thing at that moment. So pi over 4, that's gonna be root 2 over 2. True? Okay, that'd be root 2 over 2. And you please ask me the questions here. And I want to just give you like the nearest 10th or nearest 100th of it. 0.8.
So I have 0.71 and then also 0.8. I would 0.71 round up to 20.
I don't know.
I pointed on one side, pointed one.
Shouldn't it be 0.7? Like, is that just a computational error or is that something else?
I don't know. Let's see. You guys, I think it's 0.71. This should be
0.71. This is 0.707.
Then it should be 0.7 as well.
0.7. Yeah, 0.7, 0.71.
Okay, but
That's
then on
close.
the next one, I have 0.87 and I also have 1.1. That's
Yeah, same.
And you have a what?
1.1. I think these were
Interesting.
different numbers. I think, oh, is this how many?
So let's do this here. This would be your square root of 3
is
over
this how many
2.
radians there are?
Wait, yeah,
And
so
is
does
that-
this
is
give
that-
us the y? of
Gotcha.
those
Yes.
points?
So it is the exact amount of radians.
It's the y coordinate.
It's the y coordinate,
Uh-huh.
the t is not the x coordinate.
No. T is the length from 1, 0 around the unit circle. Cool. All right. Let's jam. This guy gives me point what? What's the square root of 3 over 2?
It's from 1, 0 or 0, 0?
From 1, 0. From this little dot right here. The length around the unit circle from that point.
0.9.
0.
0.87.
0.87, yeah. I mean, I'm going to put 0.87 here just to have a little bit more clarity, but if we put 0.9 last time, that's cool.
And then,
And this guy is just 1. Hey, that's right, that's just 1.
and you translate these to like the radian values by just multiplying them by pi over 1 radian, right? Or how are you trying to do that? Like, how would you get the 1.1 that's still 0.87?
On the calculator, just put square root of 3 divided by 2.
If that's
We're just solving the actual coordinate then.
We're just to the nearest 100th or so, yeah.
Okay.
Coolio, we're good there. And Dylan, are we good so far?
I'd appreciate if you go me a bit slower.
Sure, yeah, no problem.
Solve First, the second one.
No problem.
Basically, what are the numbers on the other side?
That's just solving the coordinate, like root 2 over 2, you actually divide root 2 by 2.
Okay.
So now what we want to do, and Dylan, slow me down, okay? So tell me when you're good. The next part is important as well. So we have this in terms of
Wait, I just did root 2 divided by 2 and I got 0.7.
0.707.
0.707,
But you'd round that up, I got 0.707, which is 0.71, but then, so where's the 0.8?
We'll get there in just a second.
Okay, is that something else that we'll get to?
Yeah.
Okay, because I was just confused. Oh, just you
0.8.
went back now to this value. Okay, I was just confused because I thought that was something we were supposed to get to.
Gotcha. No, just making sure that Dylan, next computation we're gonna do. So notice on the right-hand side, we have the sine of t values, right? They're decimal approximations. So Dylan and P, let's go this way. Let's convert these guys into decimal approximations as well. So I'm gonna have decimal approximations on both sides.
Oh,
Now,
okay.
So pi divided by 6 is what? 0.5? Pi divided by 4 is what?
That makes sense.
Sorry, point how much?
0.8.
0.8, okay.
Are we rounded up to this?
Nearest 10th, nearest 100th, it's all gonna be similar. Okay, Pi divided by 3,
1.1.
1.1, and pi divided by 2.
1.6.
Yeah, 1.57, but technically 1.6. All right, almost there, guys. This is so cool. Okay, so I take this and then we'll make sure Dylan is caught up. So we have this both at the same time. Here it is. Here's the logical sequence is. Why do I have this as, and Dylan, here's where I'm going to switch the tables on you. Ready? This comes off the unit circle, true? See, here's what I'm going to do. I'm going to make this guy to be a x coordinate on an x and y plane. Again, not the same as this guy. And this guy's going to be my y coordinate on a graph sheet of paper that says this, x and y axes.
And then y is gonna be the same exactly.
So in this case, the y will be the same value as sine of t.
And why, what is the reasoning for changing it to x to y?
So then you can plot
So the
Like
reason,
what,
yeah.
where, like, I understand what we're doing, but why? Like,
Sure.
what does that show us?
Yeah, because so far we're stuck on a unit circle and we just go round and round. We have this whole world of mathematics that have parabolas and they go like this. We have cubic functions, they go like this. We have linear functions, they go like this. We have a whole world that does this, and yet with the trig functions, we're stuck on a unit circle. And so if we just say, look, we're just gonna plot these. We're gonna plot these onto an x and y grid. And what we do, we start plotting, and the plot looks like. Oh, sorry. And so if we plot them out like this here, let's go with, we're gonna extend this out a little further because we usually don't handle the negative values as much. But let's do this here. The highest point we're gonna get is 1. The lowest is -1. And we're gonna go out, let's see, where are we at? 1.5? 1.6. So let's go out like 1, 2. Actually, no, I'm gonna go like this. I'm gonna go out 1, 1. Come on, 1. Come on, Mr. Pin. Let's go, Mr. Pin. 1, 2, 3, 4, 5, 6. I'm gonna go out to 7. That's where I'm gonna go. In fact, 6.5. I'll go to 6. This will be my 6, 5, 4, 3, 2, 1. That's what I'm gonna do. Okay, so now let's just plot these guys here up to here. 0, 0 is plotted. There it is. 0.5, 0.5 is plotted. So half here and half there. That's where I'm at right there.
8.7.
Okay, yeah, perfect. 0.8 and 0.7. So 0.8 goes up to 0.7.
And 1.1, 1.87.
Cool, okay. So a little past 1, 0.87, that's a little even higher. Boom.
1.6 and 1.
Perfect. Okay, so 1.6 hits a 1 value. Okay, we're good there. I know going back and forth. Dylan, are we good there? I'm going back and forth between the graphs.
Yeah, it's just,
Okay, no problem, no problem. I'd rather, especially in this one, because we do have to know where all the pieces come from. Isn't it funny? Like, I always find it funny, like in elementary school, you know, whenever we learn something, right, we just repeated it 5 times and we learned it. And it was like, we actually enjoyed the concept of repeating something, right? And then when you get to middle school, then you're like, oh, then you start thinking about like, how does this logically make sense, or how does this process, right? So then you get to like a high school level and you actually do have to, there's a curiosity, but you actually have to know what it does in order to memorize it, or know what it does in order to actually even understand the pieces.
Sixth grade.
So here's the top of it. We good? We can go through the whole thing. We did it last time. We went through the whole thing. So now let's go back to what we learned here last time. Last time was,
I think we roughly got to this point last time.
yeah, so we had a whole bunch of them right here. It's the same exact process. We did it all the way out to 2 pi or 6.3.
Because then it just flips out to 0, right?
Yeah, so then we got a graph that looks like this. It went up right here and then went down. So 1.6-ish.
You really only need to know how to do the first.
Correct. Yeah. So on our graph, so maybe like a little bit past 3, we would have that pi there. It'll pass 3, it'll go down and it'll come back up at pi.
Didn't you say that this is basically like you just take a circle and roll it out, basically?
So I'm thinking,
And then we want
that
to
right there.
with that, right?
Yeah, let's see. 3 pi over 2, remember the bottom of the unit circle like this? This is 4.71. And so 4.7 would be right here. We should be down to -1 here. And when we get to 6.28, we should be here. So it's these little dots like this. So if we dotted it out, it would look like that. Sorry, it's kind of getting condensed because my 5 and 4 and 6 are closer together, but it should be spread out. Okay.
What does oscillation?
Oscillation means anything that will go up and come back down and go back up and come back down. Anything in the world that does that, now we can model this. So a few things here from this one. Stock market, yes.
That's not really consistent.
And the patterns are, yeah, the stock market is kind of funny. Most people say there's a triangular pattern or a trapezoidal pattern in there. So they try to fit those into the pattern there. Real quick here though, important concept here. Instead of, notice what we did is we took the decimal of these guys. And for our graphs, what we're gonna do is we're gonna change our, instead of going 1, 2, 3, 4, 5, 6, because then we'll have to approximate all the time. I don't want that. So on my graph, I'm going to, for sure, use 0, 0 as an important point. And this is called critical points now. I'm going to use the max point that happens. That happens in actually 2 pi over 2, sorry, pi over 2, we good? So I'm going to use that as my very important point. I'm going to use pi as my important point because that's what happens when it hits 0. And I'm going to use this point right here. So it's 4.7 or 3 pi over 2. That's going to be an important point for me. And then eventually 6.28. What is that, guys?
Full circle, right?
X value over there?
It's 2 pi.
2 pi. Perfect. Okay, so real quick here. 0, pi over 2, pi, 3 pi over 2, and 2 pi are going to be my critical points. Because those land me my zeros, those land me my max and mins, as long as I have that. So whenever I graph this, I'm no longer going to use 1, 2, 3, 4. I'm just going to use pi over 2, pi, 3 pi over 2, 2 pi.